It's Thursday, the 23rd of February 2023, and welcome to the Water Action Platform, where we proudly share stories from across the global water sector. Now, this is our 49th broadcast, and with the addition of new members from Suriname, we now have membership which reaches 109 countries. Today, we have 30 minutes and 6 amazing stories to share with you, including a brand new feature called Both Sides Count, in which 2 water sector leaders participate in a short, punchy debate with the ever-present question of what do they really believe hanging over them. You're going to love it. However, we must start today with the Turkey-Syria earthquake. On February the 6th, 2023, 2 massive earthquakes struck southern central Turkey and the northwestern part of Syria. The death toll is relentlessly rising day after day. So we reached out to the dozen or so registered Water Action Platform members that are based in that region to see how they were and to hear firsthand how the earthquakes had impacted the water and sanitation services. One of my Isle colleagues, Mazin Salah, has been able to speak with various trusted sources from within Syria about how they are affected. In particular, we've spoken to Mr. Khalid, who works for the Orange organisation, which operates in both Turkey and Syria.
نتيجة الزلزال المدمر اللي ضرب هاي المنطقة كان له أضرار كارثية مثل ما تفضلت من شوي على كافة الأصعدة من ضمنها مياه الشرب ومياه الصرف الصحي. المياه أصبحت غير صالحة للشرب بسبب اختلاطات التربة الملوثة بفضلات الإنسان والحيوان. مياه الري نتيجة الزلزال أصبح هناك إغلاق لقنوات الري، لأن دائما عندنا نحن قنوات الري بالشمال السوري عبارة عن قنوات ري مثل مجاري أو سواقي أو يعني شيء بيشبه القنوات اللي نحن بنسميها الشقق. فبسبب الزلزال أصبحت هاي القنوات مسكرة والناس غير قادرة على تأمين مصادر المياه لإنتاج محاصيل زراعية.
Now, the full interview is on our website, but Mr. Khalid has told us that 90% of the water networks are destroyed. Valves don't open, pumps don't work, springs have dried up due to the movement of the earth or are now contaminated and produce red water. The sewers have cracked and are leaching into the water supply. Service reservoirs are broken. Now, I know many of you watching have worked or are working today in water utilities, and just imagine how you would cope in that circumstance. The transport of water into the region is currently being achieved through water tankers, but even this story is heartbreaking. Let's go back to Mr. Khalid.
بالإضافة لهدول المساوئ أو الشيء اللي ذكرناه من شوي، فأصبح طريقة نقل المي كون إنه هاي الشبكات اتدمرت، فأصبح طريق الوسيلة الوحيدة لنقل المي هي أصبحت الصهاريج أو الخزانات المتنقلة، اللي هي بالاساس تعتبر غير صالحه للاستخدام بسبب احتواء على ترسبات او احتواء على صدى. وبالاضافه لذلك تم تسجيل اكثر من حاله دهس. يعني اليوم الوسيله اللي صارت لنقل المياه هي الصهاريج عم بتمر من خلال شوارع وازقه ضيقه جدا، فتسجل اكثر من حاله وفاه واكثر من حاله دهس من خلال النقل واستخدام هاي الصهاريج. كونها عم بتمر بأزقة ضيقة فأصبح هناك عدة حالات انقلاب صهاريج أو أصبح هناك عدة حالات لدهس.
The roads are so damaged that the water tankers, which are so vitally needed, cannot make it into the area without causing further pain and death. That is absolutely heartbreaking. Now, in the interview, Mr. Khalid goes on to talk about how the agricultural irrigation systems are also broken too, which means that this year's crops will not receive the water that they require. This catastrophe will continue for many, many months, and our thoughts and prayers are with everyone suffering at this time. We now come to Moonshot Missions, a non-profit collective of experienced public sector managers and officials based in the United States. Now, they have a mission to help underserved communities achieve transformative projects. Moonshot Missions is the brainchild of George Hawkins, the former chief executive at DC Water in Washington. Now, George is a man with incredible leadership skills. He has this infectious enthusiasm that, coupled with a burning desire to help others. Now, I've known George for many years, and when he left DC Water in 2018, I was genuinely worried that our sector was about to lose someone particularly special, that he'd focus his attention elsewhere. I'm delighted that that worry was misplaced. I spoke to George last week about what the Moonshot Mission is and how it's going. George, brilliant to see you again. It's been too long. I know you've been really busy on something called Moonshot Missions. Let's start by telling me, what is Moonshot Missions? Why was it formed? What are you trying to achieve?
Sure, and it is brilliant to see you, Piers. It has been way too long. And I've learned a lot from you that is about Moonshot. So you'll hear echoes of what you've been doing, because it's my judgment, having run a large water utility like you were part of a large water utility, that there is not a technology problem in water. There are more solutions and approaches that can solve most of the water problems that seem dire and are dire around the world. And that's not the issue. The issue is technology adoption, the hesitancy, the delays, the caution, the challenges of adopting all these strategies. And that occurred to me when I was at DC Water, the utility I used to run, when I'd make presentations about all these things we'd done, and utility chiefs from smaller, from under-resourced, not a lot of extra personnel or funds. So that's a great story you tell at DC Water with your large budget and all the rest. Doesn't relate to where we are. We're not anywhere near being ready to adopt those strategies. And that the issue on my mind then, like I know it has been on yours, is how can we encourage the adoption? The model that the moonshot was the question of how to help those utilities get on the path of technology adoption to really transforming in the ways we know they can. So that the technique that Moonshot has decided to adopt to address that question is a peer-to-peer network, in essence. Moonshot is comprised of all utility veterans, because the change that's most challenging is encouraging utility professionals to think about, adopt, experiment with new approaches. And that's a hard obstacle to overcome. It is helped if we are talking to as another utility person. So we're in the same world. We understand your role, you understand ours, and we've done it. So we can walk you through with the experience of having accomplished many of the outcomes that we are seeking to help you do as well. And so
let's get some stats now. So because you left DC Water in 2018, and so you're 3-4 years into this. How many utilities are involved? Can you give me a case study, something, an example of something that you've done?
Sure. And by the way, it's turned out that the Moonshot approach works with larger and well-funded utilities as well.
I was going to come to that, because it feels like the need you described is almost irrespective of size. But anyway, let's come to it.
And one of the other elements that Moonshot was not the reason I established it, but has turned out to be a strong asset, is that we don't come into the utility selling anything in particular. So we have no stake in whether they choose or not choose. And it takes away the sales notion of the engagement. We're just giving you the best options and ideas that we have. And bigger utilities that are well-funded, their C-suite level management often don't have anybody to talk to like that. Who's a group of people who know the job, who've been in the job, but aren't trying to sell me anything. They're just trying to help me chart a path. So we have an arm of Moonshot that has been supporting larger. We're helping Miami-Dade Water and Sewer Department, one of the larger water utilities in the United States, chart their strategic plan. We've worked at Pittsburgh. It's in Puerto Rico. So bigger utilities who just want that kind of unbiased, trusted advice of good paths forward.
And how's it funded? So you parachute in a group of people to do a sort of forensic test, as a forensic analysis of the state. How's that funded? The utility pays for that?
It's a great question, and that's what's changed. So since you and I have been talking about these ideas, because I know the Isle utility does a very similar role, and the challenge that we had building Moonshot in the first few years is we're trying to basically help utilities that have no money. That's why we want to help them. That's a hard market to help utilities with no money. So we were slowly growing, because in those early years, the only way we could do that work is if we found somebody to subsidize our costs. And that was mainly philanthropy. And I have to say, most foundations had never thought about helping an organization whose goal was to help a water utility. It's not that you couldn't eventually persuade them. It's not a topic that was on their minds. So that was slow and steady growth as we could persuade philanthropy. What's changed in the United States is the bipartisan infrastructure law, because what it provides is this unprecedented level of infrastructure funding. We all understand that we want that funding to go to transformative projects. So not just replacing old things with new things, but new things with added features and approaches, just like we've talked about. And the Biden administration want those funds significantly to be going to exactly the kind of marketplace we've been in, which is under-resourced. They're called Justice 40 communities, and they need technical assistance. What EPA has done is set aside funds over 5 years to pay for technical assistance. We are actually talking with utilities in Canada. That's not quite the rest of the world, but it's expanding in North America. And we talked to the World Bank, and the model of having utility professionals without a motive, it's like Doctors Without Borders, going in and helping to assess and identify and particularly starting pathways. What I've seen from a lot of the tech firms who are wonderful, but they come in with pretty sophisticated solutions which aren't really targeted to this entry point of a utility that has far less resource or far less capability to start. And that starting point is getting on the path. I think it's a model that could work almost anywhere.
So, if you're based in North America, then I encourage you to reach out to George and the Moonshot team. And if you're not, well, if you're approaching retirement and want to use your experience, your skills, your knowledge of what works and what doesn't to help others, then let me know, because as George said at the end there, it's a model which could work anywhere. So let's make Moonshot Mission global. We now come to our technology showcase, and this week it's the advanced oxidation company Infinite Water. Based in Australia, Infinite Water provide a variety of water and wastewater solutions, but today we're going to focus on just one of them, the Hydroxon process. Now this uses a combination of catalytic oxidation reactions to remove dissolved metals by causing them to precipitate out of solution. Advanced oxidation processes, or AOPs, are highly effective at fragmenting and degrading organic matter. What makes Hydroxon different to other AOP processes is that it doesn't rely on energy-intensive processes to generate the reactive species. Instead, the reactive species are released through a series of chemical reactions when the water to be treated is brought in contact with the catalyst. So here is Dr. Agatha Walczuk, co-founder of Infinite Water, talking more about what they do, and in particular about a trial that they've just completed with Sydney Water.
Hi, I'm Agatha Walczuk, Executive Director and Co-founder at Infinite Water. Infinite Water is a water treatment technology developer and integrator. We focus on solutions to some of the world's most pressing water issues. And today, we'd like to showcase a collaborative research project that we undertook with Sydney Water using our proprietary Hydroxon technology. The project was designed to destruct natural organic matter from surface water catchments at the Sydney Water's Nepean site. With the increase in population growth and extreme weather events, natural organic matter and disinfection byproducts in the form of THMs are becoming ongoing issues for municipalities across the world. So here is Harry Bustamante, Principal Scientist on Treatment at Sydney Water's Research and Innovation team, to go through the details of the project.
The problem that needs research and that we are trying to solve is that there has been a gradual increase in natural organic matter, measured as dissolved organic carbon, in the raw water, particularly after heavy rain events. Natural organic matter, or NOM, is a broad term for a complex mixture of naturally occurring compounds that mainly give color to the raw water. The increases in natural organic matter, particularly after heavy rain events in Sydney's catchments, impact the performance of the direct filtration plant, resulting in reduced flock strength and therefore plant capacity. Failure to successfully control the issue could result in expensive upgrades to the treatment processes at Sydney's 9 water filtration plants in the next decade. Sydney Water is engaged on a broad research program to identify novel technologies and novel polyelectrolytes to improve the removal of natural organic matter from the water coming into the treatment plants. The Hydroxon technology has previously demonstrated high efficacy in degrading and removing NOM and dissolved organic matter. Sydney Water entered into a collaborative research agreement with Infinite Water to establish if the increased NOM can be reduced prior to the filtration plants using the Hydroxon process. Infinite Water installed and operated a 5,000 liters per day continuous pilot scheme at the Nepean water filtration plant to evaluate the performance of the technology. The pilot plant was operated during Sydney's long-lasting heavy rain periods early in March 2022. The dam water at this time was characterized by high dissolved organic carbon and high color. The technology achieved an average organic reduction of over 70%, significant improvements in true color removal and disinfection by product formation potential in the treated water. The Infinite Water's pilot results are very promising. We believe this novel treatment technology can be tested over a longer period to improve the existing natural organic matter removal processes, thereby ensuring a continuous supply of drinking water across our network. The main highlights are there for the Hydroxon technology consistently produce drinking water with low residual color, achieve up to 70% NOM removal from around 9.5 down to 2.8 milligrams per liter. This was an excellent collaboration with Infinite Water because the Hydroxon team fully understood the scope of the project and followed the monitoring plan that we had designed. This allows us to identify the performance of the various stages of the technology and identify components that could be improved.
Infinite Water are currently fundraising, so if you're an investor and you saw something there that caught your eye, let me know. Staying with new technology now, let's have an update on the recently completed trial, which was funded through the Trial Reservoir initiative, which uses just a brilliant technology. It's one of my favourites. The technology uses magnetic nanoparticles which have a special coating on them so that they can remove specific contaminants. It's just brilliant. Here is Joe Burgess to share more.
Thanks, Piers. Yes, today we're zooming in on California in the USA, where technology company Advantaegous Systems, or ADS, recently wrapped up their trial. Linneman ranches produce tree nuts, predominantly almonds. Their orchards are irrigated during the dry seasons using borehole or well water. The groundwater in the area has a high total dissolved solids content in general, and high boron concentrations in particular. The aim here was to drastically lower the electrical energy demand of water treatment without compromising the treated water quality. The ADS MPT system uses micron or nano-sized magnetic particles that have receptors that are selected to trace elements, such as boron or selenium or arsenic. The MPT can be used standalone or in conjunction with other systems like a reverse osmosis system, and it comprises three main components. So first, the injection of magnetic particles. Second, the mixing process or the residence time that puts the particles in contact with the water. And then thirdly, a magnetic removal system that uses permanent magnets to separate the particles that now have the trace elements attached to them from the water without needing a lot of energy or a lot of pressure. This particular trial used the MPT system to selectively remove boron upstream of a reverse osmosis system, removing the need for double pass or two-stage reverse osmosis. Our CEO, Ben Tam, visited the site recently. He went to see MPT for himself and to speak to ADS's staff, Adam Stein and Baryohay Davidoff.
The Linneman trial was a 500 GPM or 500 gallon per minute system that created at least 4 acre-feet per day of water. This system utilizes the MPT system prior to an RO system, and this trial was a successful unit and really provided enough clients in the respective area interested in getting water credits from the water districts based on the quality of the water that removed both boron and TDS. This system utilized less energy and effectively allowed for RO to be able to be used because the boron was removed.
It's full operation that they are irrigating this field with the water that is being treated by our system about a mile down there, and the water that we take from groundwater is salty, and we take that one and we get like 2 gallons out of 3 gallons fresh water, and the farmers can use it to their benefit, and especially that when the water shortages are there, as we have it for many years, they love it.
The system was deployed very rapidly and very effectively. What didn't go to plan was the well. The well sometimes had some cavitation issues and some startup issues. The energy demand on that location also didn't have enough amperage, so we were forced to use a generator for a time, and we would have preferred a solar generator, and we are effectively working on that right now, albeit not completed. The next time we put in a full-time system, we would have a full solar to power that system. The CO2 savings so far is vast. If we look at CO2 emission on a double pass RO, on a brackish RO system, we would see anywhere between 1/3 to 1/2 more CO2 emission with a double pass, specifically with high boron rates that might have a double, triple pass or a double RO full system.
All the farm's needs for water quality and volume were met, and the MPT system saved between 35 and 50% of the energy consumption by replacing the old 2-stage or double pass reverse osmosis system with MPT and a single-stage RO. Now, Adam mentioned water credits. Groundwater trading has been an important tool in California for decades. As well as having enough water for their own needs, now that Linneman ranches can treat this water to a suitable standard, they are permitted to give it to the water district in return for water credits, which they can use on other of their properties in the same district, or they can sell them to other farmers. And the very best outcome of this trial, in my opinion, is that Linneman Ranch's neighbours have been to see the ADS system, and now they all want one. And on that note, I'll hand you back to Piers.
Thank you, Joe. As Joe mentioned, having seen the success of the Linneman Ranches trial, there's now a pipeline of other farmers who want to install the ADS technology, ideally before the irrigation season starts. It's a wonderful success story, and I can't help but wonder if we could link it back to the challenges in Syria and Turkey that I mentioned earlier. There's definitely something there to think about. We now come to a new feature called Both Sides Count, in which we invite 2 senior people from the water sector to present the case for or against a particular issue. Now, the key feature of this new segment is that the debaters making their cases might actually be arguing for a position that they don't personally agree with. Why? Well, because we think it's increasingly important that in today's polarized world, we can show that there are 2 sides to most topics, and that even if we have a firm position, reasonable people can understand the arguments from the other side. So, for our first Both Sides Count debate, we have George Hawkins, whom we saw earlier, and Andrea Gysin, Net Zero and Innovation Director at WSP. And the topic we gave them to wrestle with? Well, it's that age-old water sector conundrum. What's better, public ownership or private ownership? If you want to join in, click on the purple triangle to the right of your screen to open up the chat box and click on the poll. In particular, if you want to share your view, or whether your views changed after you've heard George and Andrea speak, please add a comment. Otherwise, sit back, and enjoy the show.
Privatization of water utilities is exactly the right outcome because we all know there's not enough money ever to solve the water issues that we have unless two features which privatization brings can be brought to the forefront. One is a constant drive to invest to improve and reduce costs. Private companies by their nature are seeking to improve their balance sheet, so they're by nature always investing to optimize efficiencies. The second is scale. Private companies can work across boundaries and can get the best personnel that a smaller, unique utility can't on skill, and as well as having the knowledge to share among all their various entities. There's no other way that you can manage water utilities in today's world.
The water industry fills this vital societal function and a vital environmental function. So it's absolutely critical that that is governed by the public interest. And whilst we see private utilities in the UK, for example, committing to enhancing public value, it just is so important that we don't leave that to the chance of private investment doing the right thing. So we really need to get alignment with policy. And of course, we need to get alignment across the various risk authorities. So it's not just water utilities and the water utility function that needs to be aligned to those outcomes. It's also other risk management authorities, whether they're local authorities. And that is much easier to do if you've got that fundamental alignment with greater public outcomes.
There's another, this angle of cost is the driving force of any infrastructure agency, and a private company is able to share those costs among a broader rate base. It also is presenting those costs to a professional entity which approves rates rather than a municipal government of elected officials. And that professional rate review is a standalone issue that opens the door to the investments that can prove the future.
So I think this is nowhere more apparent than in the current challenge that we have around climate change and net zero and some of the interventions we need to make. If you take, for example, the challenge of delivering low carbon heat, the water company infrastructure, so sewerage, for example, is a great source of low carbon heat. But there's very little motivation today for water companies to make that heat available because actually the value, the carbon value, the economic value sits at the point of end use. So if we were in public ownership, we wouldn't have that barrier.
In sum, the privatization of water works because we can invest money to constantly improve services. We gain scale for personnel and expertise, and we have a professionalized rate review system that allows and enables in investments. That's a winning combination.
So in summary, if we look at what we want from the water sector, we need a sector that is aligned to societal outcomes, and those are both around the people, the built environment, and of course the natural environment. And aligning those outcomes to policy and regulatory objectives is much easier if the finance that controls the investment is also controlled by those same public bodies.
So, I mentioned that part of the beauty of this segment is that the debaters might actually be arguing for a side which is contrary to where their real heart lies. We do this to emphasise the fact that most sensible people can understand both sides of an argument. It doesn't always need to be a polarised discussion. So with this in mind, it's only fair to give the debaters their moment of truth to share what they really feel.
My real thought on this is that actually there is no single answer to this question because every model works given circumstances. I like the public model because you don't have to generate a return to investors, and you can do all those things of return on investment. I like independent private, like an authority, but I also think private systems, for all the reasons I said, are absolutely the right call in the right place. So all of those options work depending on circumstance.
So my position on this is there isn't really a single right answer, and both models can work. And actually, if we look at what privatisation has done for the UK water industry, the level of investment that's been made and the huge increase in water quality standards and environmental performance that we've seen, it has arguably been a success for the UK. And the reality is all those issues and barriers I mentioned can be overcome by good collaboration. We just need to have the right parties around the table motivated to collaborate. So I think both models can work, but I'm a huge advocate for making our privatised system in the UK work to its fullest potential.
Wasn't that brilliant? Thank you, George and Andrea, for being so excellent as our first debaters. Now, if you've been watching this and thinking, hey, I'd love to do that too, then let me know, because this is going to become a regular feature. And finally, the Inuit people famously have over 50 words to describe snow. The Sami people in the northern Norway have over 180. Yet in the English language, we apparently have just 12. Snow, hail, sleet, slush, icicles. I can't get the remaining 7, but I'm assured that they exist. Well, brace yourself, because we now have a 13th. In an astonishing new development, scientists have created a new type of ice called medium density amorphous ice. Now, this discovery, reported last week in Science, could be a crucial step in studying the mysterious properties of water. As we all know, normally water freezes and crystallizes into a hexagonal structure that we call ice. Ice is less dense than liquid water, so it floats. Amorphous ice is different. It has no ordered structure. Its molecules join haphazardly. Now, this new medium density amorphous ice was created by shaking a regular ice in a container with stainless steel balls about 20 times per second and at minus 200 degrees C. X-ray diffraction analysis revealed that it had a molecular density similar to that of liquid water, but the lack of an ordered structure meant its crystallinity was destroyed. Now, fascinating as though that is, it begs the question why? Why is this relevant, and why has it been studied? The answer is very exciting, because previously 2 types of amorphous ice had already been discovered, referred to as low density and high density. They're both abundant in space, and some comets are composed of low density amorphous ice, for example. The discovery of medium density ice challenges the commonly held idea that low and high density were the only 2 forms of water available. Now, this discovery could enable new studies of liquid water that were simply previously impossible. For example, such studies could shed new light on other worlds, such as the icy moons in our solar system. The existence of medium density amorphous ice could have implications for geophysics and, hold on to your hats, the potential habitability of the oceans under the icy surfaces of those planetary bodies. Now, akin to famous movie quotes, "There's no place like home," or "May the force be with you," or even "We're going to need a bigger boat," one author in this scientific paper made the following comment: "You're looking at a very disordered material." Now that, I assure you, is going to be the quote that will inevitably be made when they make the Oscar-winning movie about how this new ice was discovered. That line is going to be immortalized. With that, we come to the end of this week's broadcast. I thank once again our contributors and sponsors. Next month's broadcast will be held on March the 23rd at the usual times. Keep asking questions, keep sharing, and keep safe.